Okay, so section 6.6, now we're kind of switching gears a little bit. Still talking, this chapter is geometry and trigonometry, so obviously this is going to be geometry, but we'll be using trigonometry really more tomorrow when we're doing some of our applications of these things. So these formulas here are the formulas exactly the way they look in your formula booklet, so I wanted to use the same wording and everything. So let me kind of just jump down here and then I'll go back up to point out the formulas there. So the first one that you can see on your paper is area of the curved surface of a cylinder. So in our picture right here, and I don't have one that has color, but it would be, you know, the around the edge. So think of it, if we're talking a soup can, it's the label on the soup can. So where we're going with this is surface area and volume. So surface area is the total area of all the surfaces. So with a cylinder, it's going to be your top, your bottom, around the sides. Well, you know how to find the area of a circle, so they're not giving you that as part of the formula. They're only giving you the part that you would need, which is the around the edge part. So 2 pi RH. Make sure that whenever you use pi that you do use that you use the pi button. Don't use 3.14. Radius, of course, make sure you have halfway across. If they give you all the way, make sure you divide in half there. Okay, so next, surface area of a sphere. So if you were going to paint the sphere, how much, you're talking about how much paint would cover it, for pi r squared. Area, the curved surface of a cone. So again, think about, you know, just if you were going to, let's say a waffle cone. You're going to cover this waffle cone in chocolate. There's no cap on a waffle cone, so you're not including that circle on the bottom. But if you want to find the surface area of the cone, then you'll do that curved surface, plus you'll do the circle on the bottom. Now, this formula uses L. L is the slant height. So it's not labeled in this picture, but if you would like to do that, this would be L, and then normally they would use an H, and they kind of use a little bit of a, I kind of did like a cursive L, which kind of looks like an E, but it is an L. So notice here that there's a right triangle, so if you know this height, you can use Pythagorean theorem to find this. If you know this height, you can use Pythagorean theorem to find that height. So. Volume of a pyramid. This is a rectangular pyramid normally, or a square pyramid. Normally that's the ones that you see the most often, although you could see any kind of bottom on your pyramid. It could be a triangle, could be an octagon, could be a hexagon, could be lots of different things. So the volume of the pyramid is 1/3 A times H, and A is the area of the base. So in this case, the area of the base would just be length times width. If it's a triangle, 1/2 base times height, whatever that base happens to be, times the height, and that is the vertical height. Now, when we talk about, and there's nothing on here that mentions anything about the surface area of a pyramid, the surface area is just going to be, again, the area of all the surfaces. So in this case, you have 5 surfaces. You have 4 triangles, and you have a square. Now, to find the area of the sides here, the faces, you need that slant height. So again, you can see that right triangle there on the inside. I'm sorry here, this isn't showing up in my video. I thought it was when I was pointing. You can see that right triangle there. So if you know the slant height, you can use that to help you find the regular height. If you know the regular height, you can use that to help you find the slant height. One thing about the base, if they tell you that this edge right here is, let's say, 10, then remember in your little triangle that's formed here, that means that this would be 10. Okay, kind of like they're giving you the diameter and you need the radius kind of thing. Okay. All right, see, next you have the volume of a cuboid, and this is a cuboid. Essentially, it's a rectangular prism. A cube is a cube. I don't believe that cuboid, I'll double check, but I'm almost positive that a cuboid is a rectangular prism. Actually, let me stop and we'll figure that out for sure. Okay, so I have consulted Google, and Google says that a cuboid is a rectangular prism. So the sides are rectangles. Now, a cuboid could be a cube, but it doesn't have to be. A cube is going to have all the sides exactly the same, so they would all be squares. So anyways, so for the volume of a cuboid, it's length times width times height. So that's kind of your traditional volume. Again, if you were going to do surface area, just kind of depends on the shape of these rectangles here. It's possible you could have, you know, like say these two front ones here, which is kind of hard to see, 3D. Those could be one length and then, or one size, and then these are another size, and then your top and bottom would be another. That's kind of a mess there, but I've got top and bottom, those are the same size automatically. The left and right are the same side, and then the front and back. Now, again, some of those could be the same, but you can at least group it in twos. Volume of a cylinder. Okay, so back down here, volume of a cylinder, pi r squared h, so that's no big deal. Volume of a sphere, again, pretty straightforward formula, 4/3 pi r to the third. Volume of a cone, notice the volume of the cone uses the vertical height, which should make sense. You're filling it with something, so you want the height through the middle. And then volume of a prism, again, uses that capital A, depends on what the volume of that, or what the base of that prism is. But again, you're filling it, so you'd want that height through the middle. Now, I am horrible at drawing 3D, so I have pictures here that obviously don't need to be drawn. Make sure when you're doing your homework, it really does help to draw a picture, even if it's a bad 3D picture. Tomorrow's assignment, you're going to be doing some kind of crazy 3D things, and the color of the faces will help, so I'll have a color copy of your homework for you tomorrow so that you can write on it. Okay? So these are pretty straightforward. We're going to find the surface area and the volume of the given cone in this. Oh, sorry, forgot that I changed the directions there. This is not going to be a cone. This is going to be a pyramid. I had it as a cone, and then I changed it because we were going to do a cone at the bottom. So, okay. So for my surface area, again, I'm finding the area of all the surfaces. So in this case, since they only have given me one side of that bottom, we would assume that this is a square. So we've got the area of a square base plus 4 triangular sides. Now, if it is a square, which I'm telling you that it's a square, then all 4 of these triangles are going to be congruent, so that'll save us some time here. Now, in order to find the area of those triangles, though, I need the slant height. So I need this right here. So you can see I've got a little right triangle right there, not drawn really nicely, but let me kind of redraw it over here. Okay, so this is 6. This is 5 halfway, and then I'm looking for L right there. So for my slant height, that's going to be 5 squared plus 6 squared is equal to L squared. Now, we really don't want to round this L right now, so when we do the Pythagorean theorem, we end up with that L is the square root of 61, and leave it as that till the end. Okay, now the area of my triangles then, area of 4 triangles. Okay, that's going to be 4 times 1/2 base times height, 4 times 1/2. I didn't really need to put that in a parenthesis like that, but that's okay. 1/2 5. No. We're good. We don't want 10, or we don't want 5. We do want 10. I was thinking I'd written the wrong thing in my notes here. 10, and then the square root of 61. Because when we're doing the area of our triangles here, going back to this picture. Okay, so this is 10. This is the square root of 61. So that's my base and my height. Okay, so we're doing the times 4 because we've got 4 of those. It's up to you how you want to do that. I kind of like to do it all in one big swoop here. If you type this in your calculator exactly the way it looks, we end up with 156. Now that's to 3 sig figs. We're going to add that to the area of the base. So that's going to be 10 times 10 is 100. So my total surface area is going to be 156 plus 100, so 256 millimeters squared. Okay, area is in square units because you're taking a side times the side, so millimeters times millimeters is millimeters squared. Okay. Now volume is actually easier than surface area. I need the height of my pyramid. The height is equal to 6 millimeters. That goes up through the middle. And my formula for the volume is 1/3 AH, and A is the area of my base. So A is equal to 10 times 10, which is 100. So my volume is 1/3 times 100 times 6. Well, this actually turns out exactly because that's 600. A third of 600 is 200 millimeters cubed. And that's because we took millimeters times millimeters, millimeters squared, times another millimeter is millimeters cubed. Okay? All right, next. And I just realized I forgot to talk about prisms. So let's go back here for a minute about prisms, because prisms can be a little bit tricky. So whenever you're doing the volume of a prism, and yeah, I don't know what happened there. I thought volume of prism was volume of pyramid. So sorry about that. Volume of the prism depends on what your base is. So when it says the area of cross section, that's the way it's worded in your formula booklet, but that actually means base. And in this case, you can see this is a pentagonal prism. So my bases are pentagons. This is a triangular prism. My bases are triangles. Now the thing that's tricky is the base is not what's on the bottom. So if it's turned on its side, the triangular prism especially, it might be laying on this rectangle, and the triangular prism or the triangular faces are, kind of the opposite direction. Those are still your bases though. So it's kind of the shape that's different. Over here with the cuboid, it doesn't matter which one is the base. You're using a different formula for that anyways. But do keep that in mind that in a prism, your base is the side that's kind of different, and you're going to have two congruent ones there. So volume of the prism, area of that cross section times the height. So in this case, area of the triangle times the height, and the height is the distance between your bases. Sorry, that's horrible there. Distance between the bases. So this, yeah, definitely that's the height. But when it's turned sideways, that's not quite as obvious that that's what your height would be. Okay. Okay, so back to our prism here. So for my surface area, again, the surface area is definitely the hardest here. Let's figure out what kind of surfaces we've got going on. So this is a triangular prism. So my surface area here, I'm going to have two triangles, and they will be congruent, plus 3 rectangles. Now the 3 rectangles are not congruent in this case, but the 2 triangles are. Okay. So to find the area of my bases, I'm going to take 2 times 1/2 base times height, 2 times 1/2. Okay, so my base is a right triangle, so that's nice because base and height in a right triangle are your legs. Here's 16 back here, which means it's 16 in the front too. So that's going to be 1/2 times 12 times 16. The 2 and the 1/2, those cancel out. So 12 times 16, that's going to be 192 for my triangles. Okay. Now for my rectangles, I have 3 of them. I'm going to start with the one here on the top right. So this triangle right here is a 9 by 16. So for my rectangles, let's pretend that says rectangles. Okay, so we have a 9 by 16. All right, the one over here on the left, that's going to be a 9 by 12. And then on the bottom, that's going to be a 20 by 9. So we add all those numbers up. That's going to be 9 times 16 is 144. 9 times 12 is 108. And 20 times 9 is 180. That gives me 432. So now we add those together. Total is 192. Now remember, that's my 2 triangular bases plus my 3 rectangular sides gives me 624 centimeters squared. Okay. Now volume, again, is easier in my opinion. Your volume is A times H, and again, A is the area of the cross section or the area of my base. So my base here, we'll just say A of base. That's going to be 1/2 base. Well, we've already done that. 1/2 base times height. That's going to be 96. Okay. So now my height is 9, and that's again the distance between the 2 triangular bases there. Show right here. This is the distance between the 2 triangular bases. Okay. So now I've got the 9. So volume is equal to 96 times 9. That's going to be 864 centimeters cubed. All right. And the last one of these, we have some kind of interesting shapes put together. Now you have several of these types of questions in your homework, so again, let me know if you've got questions about any of those. So the surface area, we're going to do both of these really. We've got a cone plus half a sphere. Now, the half of a sphere, it doesn't make any difference for the surface area and the volume. We're going to do those exactly the same. When I talk about the cone, though, the cone, because we're putting the sphere on top of the cone, the surface area, we're not going to count the top, in this case, I guess, of the cone, the circle part of the cone. We're not going to count that in the surface area. Not a big deal, because my formula doesn't even have that as part of it anyways. So let's look at the cone here first. So for the cone for my surface area, I need that slant height, which they did not give me. Normally they don't give you both. So my slant height is going to be 8 squared plus 10 squared is equal to L squared. And we end up with it, L is the square root of 164. Again, leave that for as long as you can there. Okay, so my area of the slanted area here, which is what I want, or the curved surface, is pi RL. So that's going to be pi times 8 times the square root of 164. And remember, if they had given you the diameter, make sure you divide that in half. Type that in your calculator, and then go ahead at this point and round to 3 sig figs. I didn't look to see exactly what it is the book did, but go ahead and look and see if they kind of carry that over. I showed you how to store things, so if you want to store that, that's fine. But I think honestly it's going to be fine for you to go ahead and just round that right now. My half a sphere, we're just going to take that sphere formula times a half. So 1/2 times 4 pi r squared. So you could go ahead and make that be a 2 if you want. In fact, let's go ahead and do that. Half of 4 is 2. So 2 pi 8 squared. And I haven't seen anything where they ask you to give things in terms of pi, but if they did, 64 times 2 is 128 pi, but to 3 sig figs, that's 402. So my total surface area is 322 plus 402, which is 704, sorry, let me erase that, I don't really have room. Oh, sorry, I didn't mean to erase that much. (724 centimeters squared). Okay. Now volume, we're still doing the cone plus half the sphere, but we don't have to worry about the fact that the cone is on top, or that the sphere is on top of the cone. So my cone volume is 1/3 pi r squared h. So 1/3 pi 8 squared. This time we want the height up through the middle. Now that one doesn't come out so nicely as far as in terms of pi. 64 times 10 is 640, and a third of that's not a pretty number. So just go ahead and type that all in, and we end up with 670. Again, that's to 3 sig figs. My half a sphere, we're going to take half of 4/3 pi r to the third. So that would be the same thing as 4 6, which I know we'll reduce, but 4 6 pi 8 to the third power. Again, that's not such a nice pretty number, so we'll just go ahead and do it. Now that's not 3 sig figs, but I wouldn't round to 3 sig figs right now. You're going to lose some of your accuracy. When I go ahead and I add that now, I end up
Matthew
with...
Bell, please report to the front office. Matthew Bell, report to the front office.
When I add that, I end up with 1742, and they're okay with that. They would rather see the more accuracy, I think, than you have you round it to 3 sig figs. Or you can say 1740, and that would be 3 significant figures. You wouldn't count that 0 there at the end. So those are the basics, but those should help you with what you need to do for your homework. Do look at the solutions. Those are pretty good. They do help. They've helped me when I get stuck, but if it doesn't, do be sure that you let me know.